Hello everyone, today in this video we are going to talk about electric flux. So after this video you should be able to define electric flux, derive the formula for electric flux and use this formula to calculate electric flux for different system. So to understand the flux we have to understand the area vector first. Suppose I have a surface area like this, so we can easily find the area of this surface by using the formula. But now the area is a scalar which do not have any direction, but area vector is a vector which has direction. Area vector is a vector whose magnitude is equal to the area of the surface and direction is perpendicular to the surface area. Now you can see out here I have a direction also, so this vector is the area vector for this area and this is the area vector for this surface area. So it has the magnitude which is equal to the area of the surface and the direction is perpendicular to the surface of this area. So in this diagram you can see the area of this surface is ds and this line is the perpendicular to the surface area. Now ds vector, now ds cap is the ds vector is the vector who is having the magnitude which is equal to the area of the surface and there is direction also n cap. N cap is a vector which is perpendicular to this surface. So area vector is a vector having magnitude equal to the area of the surface and direction is normal to the surface. So out here you can see the formula. ds vector is equal to, this is magnitude which is the area of the surface and this is direction which is a vector which is perpendicular to the surface area. And sometimes we may use delta s instead of ds, so please don't get confused with this. So if we have irregular surface then we divide this big area into small area and we find the direction vector for small area like this. So for this area which is ds, the area vector is like this. Now we'll understand what is electric flux. So we already know we can represent electric field by electric field lines like this. So suppose we have some electric field lines which is passing through this surface area and they are making 90 degree with this surface area. Then the electric flux is the number of electric field lines crossing the given area perpendicularly. So electric flux are number of electric field lines passing normally through a given area. So now out here suppose we have a surface area delta s and out here electric field is going like this and direction vector or area vector is also going in the direction of electric field. So that time I can write electric flux, that is denoted by phi, is equal to E into delta s. That means flux is equal to electric field into area. So I'm out here I'm using delta because I'm considering small area and small flux due to this small area. Now in this second figure you can see electric field is not normal, so that time we have to find the electric field which is normal. Now suppose I have an area delta s and suppose this is the perpendicular, that is the area vector of this surface area, and suppose the electric field is not perpendicular to this surface area, suppose it is making angle theta with the area vector. So now according to definition electric flux is the number of electric field lines which is perpendicular to the surface, but out here it is not perpendicular, so we have to find the perpendicular component of this electric field. So we can resolve this electric field into two components, one is horizontal component and one is vertical component. You can see I have resolved this electric field into two components, one going towards the angle that is E cos theta and one is perpendicular component which is E sin theta. Now you can see E cos theta is crossing the surface normally making 90 degree, so we have to consider this electric field this time. So now out here you can see if E makes angle theta with delta S, that time we take E cos theta. So our flux will be, instead of E, I'll write E cos theta, because E has to be normal to the surface. Out here we have normal, but out here we had some angle. So that's why I have resolved this into the component which is passing normally through this surface. So instead of E, I'll write E cos theta, and this is delta S. So this is the formula for the flux if electric field is not normal to the surface. So flux is equal to E delta S cos theta. So flux is E delta S cos theta, but we know A B cos theta is A dot B. So instead of this I can write flux is equal to E dot delta S. That means flux is the dot product between electric field and the area vector. So in this figure you can see there is a large irregular area. I have divided this area into small areas like delta S1, delta S2 till delta Sn. And suppose electric field at this point is E1 and electric field at this point is E2, then the total flux through this area is given by this expression. Total flux is flux through this area plus flux through this area, so on. And if you write the formulas for this flux, that is E1 delta S1 plus E2 delta S2, then total flux will be summation of all flux due to all the areas. Now if this area is very small, that is near to 0, then we can convert this summation into this integration sign. So total flux will be the addition of all the flux, that is integration of flux due to each area. So this is the formula for the flux for any closed area, and I'm making this circle out here in the integration. It is saying that the integration is closed integration. That means we are doing it in the closed area. Now unit of flux. So the formula for flux is delta phi is equal to E delta S cos theta. So we have to put the unit for electric field and area. So for electric field it is Newton per coulomb, and for area it is meter square. So unit of flux is Newton meter square per coulomb. Now so we can have another unit for this flux. Newton meter square per coulomb can be written as Newton meter per coulomb into meter. So Newton meter is joule. Now joule per coulomb is volt. So unit of flux is volt meter. So this is volt and this is meter. So we have two units. One is Newton meter square per coulomb and another is volt meter. Now we have got three formulas for the flux. One is phi is equal to E dot S. So this formula we will use if the electric field and area is given in vector form like IJK. And if angle between electric field and area vector is given, then we'll use this formula. Phi is equal to Es cos theta. And if it is for closed area, then we use the integration sign. So out here I have not used D or delta S out here, so we can use any form of formula according to our need. So this is the first question. If electric field is given by 6I plus 3J plus 4K, calculate the flux through a surface area of area 20 units in
YZ plane.
So electric field is given and area is given, but the direction of this area is not given, so we have to find. So it is saying the area is in YZ plane. So I'll draw the coordinate system like this, and YZ plane is this one. So this is the area. So the area vector will be in this direction, that is the direction of X. So the direction of this area vector is the direction of X, and direction of X means I. So area is given, but area vector, now I'm making it area vector S cap is equal to 20 and direction is along X direction. So I can write I. So electric field is given. So now flux is E dot S. Because they are in vector form, so I'll use this formula. So flux is equal to E dot S. For this I can write 0J plus 0K. Now 6 into 20 plus 3 into 0 plus 4 into 0. So if you multiply this, you'll get 120 units. So the flux is 120 units. because out here units are not given, so I'm writing units only. Now you can try this similar questions. In first question you have to find the direction of area vector, but in second case the direction of area vector is given. You just need to find the dot product between E and delta S. So you can try it by yourself. The answers are given. Now this is another question. A circular plane sheet of radius 10 cm is placed in a uniform electric field of 5 into 10 to the power 5 Newton per Coulomb, making an angle 60 degree with the electric field. So it is saying the plane sheet is making 60 degree with the electric field. Now we have to calculate the flux through the sheet. So radius is given, I can find the area, and this is the circular plane, so the area of the circle is this much. Now electric field is given. Now according to question, the plane is making 60 degree with electric field, so the angle between electric field and area vector is not given, but this area vector makes 90 degree with this plane sheet. So this is 60 and this is 90, so this angle is 90 minus 60, that is 30 degree. So theta is 30 degree. Now I can find the flux, that is E as cos theta. So if you put the values, you will get flux to be 1.35 into 10 to the power 4 Newton meter square per Coulomb. Now this is another question which is similar to previous question. We have electric field and we have the square of area 10 centimeter square. So we have to find the flux when plane is parallel to YZ plane and when the normal to the plane makes 60 degree with x-axis. Out here electric field is along x-axis, which is I. So electric field is this much. Now the area is given, that is 10 centimeter square, but we have to convert this into meter square. So centi means 10 to the power minus 2. So when you square it, you will get 10 into 10 to the power minus 4 meter square, and your area will come as 10 to the power minus 3 meter square. Now for the first case, if you draw the square in YZ plane, then perpendicular to this square, that is the area vector, will be in x direction. That time your theta will be 0 degree. So we can use the formula of flux using angle to be 0 degree. Now in second case, the normal to the plane, that is the area vector, is making 60 degree with the x-axis. So out here this is the x-axis. In the direction of x-axis we have electric field, so that means the area between the electric field and the area vector is 60 degree. So out here theta is 60 degree, so you can use the formula to find the flux. So in this case you will get flux to be 30 and out here you will get flux to be 15. Now this is another similar question. Out here electric field is given and electric field is in x direction. Because of this I cap, I can say electric field is in x direction. Now we have to find the flux through a square of side 10 centimeter. Side of the square is given. Now we have to find the area from this side. So we'll find the area in centimeter square, then we convert it into meter square. Now we have to find the flux in two cases. One is when the square is kept in YZ plane, and in another case the area, that is the square, makes 30 degree angle with the x-axis. So in this case you can see the direction of area vector is same as that of electric field, so theta is 0 degree out here, but out here you can see this angle is 30 degree and this is 90 degree angle, because this is the perpendicular vector to the area. So this total is 90 and this is given, that is 60. So this angle between area vector and the electric field will be 60 degree, because it's 90 minus 30, that is 60. So out here theta is 60 degree, out here theta is 0 degree. So you can easily calculate the electric flux using the formula. Flux is equal to E as cos theta.